On Delta Math, we're going to be dealing with domain and range. So you'll have the first section, you got a little graph that looks like this. You'll have a bunch of different graphs. But anyway, it'll tell you to do the domain or the range of the graph. So this one says determine the domain of the following graph. In case you forgot, the domain is the x values. So it's all the possible x values. Everything that's included on this graph is part of your domain. The other things you'll notice, you've got a filled in dot here and then an empty point here. That means that this point would be included in the graph, but this point is excluded from the graph. So there's ways that we can write that in our domain to show that this is just a stopping point and not included, whereas this one's also included. So let's talk about the domain to begin with. The domain, you look at the lowest x value, and as long as it continues, this is a continuous graph, it doesn't stop anywhere in between, then the highest x value is the other thing you're going to look at. So we're going to start with the lowest value, and that's a negative 11. But since that is included in, and that's a filled in dot, then we're going to use a bracket for that side. So it's going to be negative 11, comma, and then I'm going to put a 10. And then instead of using a bracket there, because this is not going to be included, this is empty, I'm going to close it with a parenthesis. And that's how it's written. It's negative 11 to 10 is your domain, and then you have a bracket because that dot is filled in because that point is included. So I can submit answer. Should be correct. And it shows you all this. It even shows you alternative notation. I could have also done it as a compound inequality. I could have said x is greater than or equal to negative 11. And this part, the equal to, includes that little dot. And then we also have the less than sign for the 10 side because it's not included. So since this point is included, we had the equal sign here. This point is not included, so there's no equal sign in below that. Sorry guys, it's early morning. But anyway, so this says x is greater than or equal to negative 11 and x is less than 10, and that's what we have here. X's value is less than 10 but greater than or equal to negative 11. Let's go to another problem. This one says the range. So now we're talking about the range. It's from the lowest y value to the highest y value. So the lowest y value looks like it's at negative 4. This comes down the negative 4, and that comes down the negative 4, and that's included. And then it also goes up to 5 is the highest, and since there's no empty circle or anything, and it goes all the way up to 5, and you can see it touch 5 and come back down, then that's also going to be included. It's going to be included on the 5, so we can use brackets on both sides, and I can say negative 4 because it's the low value to positive 5, and I can submit my answer, and it is correct. And then it also again shows you alternative notation. The alternate notation is y is greater than or equal to negative 4 but less than or equal to 5. Let's go to the other sections. Finding the domain graphically. It's a little bit different than what we was doing. This shows you there's a little bit of a break in here. So this is what is the domain of the function shown in the graph below. So since this has got a break, we get to show how to actually type that break in. But to begin with, let's just look at each chunk by itself. This part of the graph extends, that arrow means it's going to keep extending all the way to the left, which is called negative infinity. So I can go ahead, and I know it's going to go all the way to negative 2, so I can go ahead and say, okay, I'm going to use a parenthesis and a bracket. So I'll click the one that says parenthesis and bracket. Negative infinity, it's right here for me. All I got to do is click it. Anytime you deal with infinities, it's not a bracket, it's a parenthesis on that side. But then it goes up to negative 2 and it stops, so I'm going to use a bracket on that side and type in negative 2. Now there's a break. well, I can't just simply put the domain for this side. I have to click this button here. This little U here means that there's a break in the graph. And now I can do the right side. The right side, I start at +1, and it goes all the way to the right as far as possible, which we call infinity. It's positive infinity. So since I start at 1 and 1's included, I'm going to use the bracket, and then I'll use a parenthesis for the negative infinity. So I'm going to use 1, and then I'm going to click in here and click the infinity button, and that should be all good. So let's go ahead and hit submit. Before I do that, let's see. This says interval notation. Okay, never mind. I thought it was saying interval notation what this is called. This is saying that this is the answer type, and there's intervals. So go ahead and submit. And yes, and it goes through all this stuff and tells you all this and gives me my solution. Gives you the alternate notation we could have used. This notation, since there's a break in it, it doesn't say and, it says or, so it's not like really a compound inequality. There's a break in there, so it says x is less than or equal to -2 or x is greater than or equal to +1. So it's either one of those. It can't be and because there's that break in there. It's not going to be both. No number is going to be both. Let's go ahead, finding the range graphically. What is the range of the functions shown in the graph below? So the range of the function shown or in the graph shown below, we're going to start from negative infinity is the lowest and positive infinity is the highest. But there's this asymptote in here. There's a horizontal asymptote in there, and it's at x equals, or not x equals, y equals 0. It's on the x-axis. So this would be all values except for 1. This is every single value is on there except for where the x value is. So we're going to say, instead of saying negative infinity to 0 break and then positive infinity, or then 0 to positive infinity with that break in the middle, this is y is such that, let me say this again. The answer for your range, this says y such that y is all real numbers except for when y equals 0. So instead y equals or does not equal 0, that would be the stipulation there. And I'm sorry guys, I know I'm talking in circles right now, it seems like to you, but the main thing is you understand how this is written. This says all values except for 1, puts it all out there for you. You just type in which one is not included, and that's what it is. This is y, saying y is all real numbers except y is not equal to 0. So it throws an exception in there, and that's it. That's all there is to that. Hopefully you follow the math better than I'm explaining it right now.